Action.
Hi, everyone. I'm Beth Johnson, and with me, as always, is scientist Frank Marchese. And this is the Grudge Report, SETI Institute science show following Star Trek Discovery's latest episodes. Spoilers abound, so if you haven't watched the two most recent episodes, turn back while you still can. Some of you are probably wondering what happened to last week. There were several things that went on, but one of the big ones was there just wasn't a lot of science in episode 6. So we struggled to find topics. So we're going to throw episode 6 in here with episode 7 and cover both of them. So hi, Frank.
Hi, how are you, Beth?
Good. How are you? How have you been doing?
Good. Let's be honest. There is one reason as well we didn't do the episode last week is because I was traveling. I went to see a space launch.
You did. I'm envious. You went down to Vandenberg and watched the SpaceX launch.
Yes, SpaceX launched Sentinel-6, a mission to measure the height of the ocean. And the launch was in Vandenberg, which is like 4-hour drive from my house. And we went there and we collected images and pictures of the launch. And guess what? The first stage landed almost nearby the launch pad. It was
And
absolutely amazing.
that's really cool. I'm very envious that you got to see that up close and fairly personal. So congrats on a successful trip there.
Yeah, we don't talk only about space and science. We also drive to see it in person.
All right. Well, we're glad that you're back and that you had a great time. And now we are here to discuss Discovery. Ooh, it was a pair of really good episodes, despite episode 6 not having a lot of science in it. But I really enjoyed both of these, and I really feel like this series is coming into its own. It, I think it stumbled a bit in season 1 and 2. It kind of picked up, but now I feel like now that we've sort of abandoned all of the canon that we had to fight against, now we can just kind of roll with what we have. And I think that this has been really cool. Plus we've had a lot more Grudge in these last 2 episodes, so
Yeah.
really happy to see our cat back. So I know you had a couple things you wanted to talk about. Despite there not being a ton of science, there was some stuff. So what's the first topic that you want to take a look at today?
Um, so maybe we should explain that in these 2 episodes, they are trying to find, Michael is trying to find this black box which can contain a measurement of the spaceship before a burn. Maybe can you explain that exactly, reminding people what is a burn and what exactly she's trying to do?
So the burn is an event that happened, I think, about 100 years prior to where we're at now in the series. And basically, what happened is all of the dilithium went completely neutral, and it no longer prevented the matter and antimatter in the engines of most of our starships. It no longer provided that safe barrier that kept these reactions happening, and everything exploded. So they were already running out of dilithium beforehand, as we find out in these episodes. And so this just sort of broke the Federation.
Yeah.
Um, Hundreds of thousands, millions of lives were lost, tons of ships. Subspace communications eventually gets cut off a bit because there's no way to go maintain the subspace system, the network. And so Burnham is on a quest to determine what caused the burn, because in her opinion, and a lot of people seem to agree, figuring that out will help the Federation come back together. And so that's her big sort of tilting at windmills quest that she is on. And in episode 6, she recovers a third black box, which is really important because now that she has 3, she can do some calculations and figure out when each ship blew up in relation to each other, because it's now a question of, did they all blow up at once because of one event, or was there a focal point, a starting point where this whole thing just stretched out almost instantaneously, but with enough of a delay that you can notice it. And I know you wanted to talk about measuring that delay and triangulating the position in space. So why don't I let you kind of take it away on that side of it?
So what she noticed with 2 first measurements is that there was a tiny shift in the delay of the burn. So she found a third one. And they measure basically from looking at the data, they managed to basically see that the shift is, for one of the spacecraft, is 1 millionth of microsecond. So that's that's 10 to minus 12. So 1/1 with 12 zeros seconds. That's a very, very small number, right?
Exactly.
So let's talk about how do you measure a second. So if you go to the gym, you probably know the 1 Mississippi, 2 Mississippi, 3 Mississippi, but that's not the way we accurately measure the second, right? We do that only at the gym and when you're kids, and you need to have an idea what is a second.
But we have an international standard for a second, correct?
Yes, so the international standard, and I look for that because I was like kind of curious. In 1967, we defined a second. At the time, it takes for an atom of cesium to an electron in an atom of cesium to oscillate exactly 9,192,631,770 times. Okay.
Wow.
I will put this number somewhere in this video so you know. So that's means that that's a very, that's the oscillation basically of an electron in an atom of cesium. And this was defined by scientists. There is kind of a group of scientists that define standards, like what is a meter, what is a second, what is all of this, and they define the seconds like that. With such a definition, you don't reach the precision, because that's 9 billion oscillations. So it's 1/1 with 9 zero. So we don't reach the precision that they need to be able to measure the tiny shift in delay of the signal.
Okay.
However, in 2017, scientists decided that they will need to have a better clock, because we do measure on Earth at the moment events which are extremely we measure events which are with a chip which is very small, and we need to have this instrument capable of seeing this tiny shift. So they created a new clock based on strontium. I don't know much about it, but they call it a quantum clock. And there is a paper in Science that has been published, and I will post the link or show you the paper in this video. But what is important is that they reach with this quantum clock a precision of 10 to 19. So that means that they have a better precision. That's what we can measure. A better precision, so that we are now able to measure such a small shift in a second.
Okay, so we can do this measurement. So what does it mean that we finally get this third black box, and we now know when each of these ships basically exploded, when their dilithium went neutral?
So basically, by looking at the difference between the three ships, by what they call triangulation, they could try to estimate the location, or at least the distance of the source. The story is more complicated than that, because space-time is not perfect. There is distortion in the space-time. Black hole, neutron stars distort the space-time, so you have to make those corrections. They mentioned that in the show. That's kind of a good. I was very happy to hear that. And they also mentioned in the second episode that with only 3 points, you are not going to be able to estimate accurately the position in space, because space is a 3D area. So you need to have more data to be able to pinpoint exactly the location. With 3 points, you can have basically a rough idea of the distance and the location in some cases, but that's all. And this is exactly the same problem that we're having right now when we study gravitational waves. So you probably know where we build these gigantic detectors made of 3 arms, kilometer length, called LIGO. There is one in
there's LIGO and there's Virgo.
Yeah, and then there is Virgo now in Italy. And there will be soon Kagra in Japan. I think it's just starting. And there will be another one, LIGO India, in 2024.
Okay.
So while we are building those additional detector is to exactly do the same that they describe here, to get multiple measurements taken at different location, so we pinpoint exactly the position of the gravitational wave, the source of the gravitational wave. So I'm going to show a map. There is maps now released. Every time there is detection by those 3 detectors, the 2 LIGO and the Virgo, we have a map, and there is basically a band in the sky of sometimes 20 degrees, which is kind of enormous, where we know that the source could be. And what researchers do, they basically use all the telescopes in the world that they have access to, and they look in this area, and they try to find a tiny variation of light to be able to detect the source of the gravitational waves. Sometimes they succeed, sometimes they don't. And the reason they don't is probably because the time they look for, the thing already disappear and it's over. So what would be great is to have all these detectors working together and to kind of narrow down the location, the uncertainty in the sky, to be able to know almost exactly after the detection of the source in the location of the gravitational wave. That will help us to learn about the source of gravitational wave, how they work, what form them, and do some real scientific measurements, of course.
That's really interesting because we use triangulation in the CAMS project as well. The CAMS is the Cameras for All Sky Meteor Surveillance, which I've worked on. And we have to have a minimum of 3 sets of cameras in order to triangulate where that meteor comes in and where it might be going, so that there's always that possibility that we could go hunt down meteor fragments if it's big enough, and that kind of thing. And also it helps us sort of track where they come from on the sky and what meteor showers they might be a part of. So triangulation is very important in determining location and distance. So, but I obviously I don't have to think about it in that 3-dimensional space. I just have to think about it in sort of that 2-dimensional on the sky kind of thing. So that's interesting. So would it help to have a 4th one, or does it at this point, do we need some kind of other information to figure out where this started from?
Well, in the show, they will need to have more than 3, more than 4. Because there is also, as I say, the fact that space-time is not homogeneous. It's full of stars, black holes, and so on. So it's probably distorted. The signal is distorted also considering those effects. So she mentioned that they will need to use the data coming from an experiment called SB19.
Right.
So what is SB19?
So SB19 is a network of subspace sensors. And it's, so for those of you who have followed Trek for any substantial length of time, way back in Next Generation days was the start of the Vulcan and Romulan reunification process under Spock. And the 7th episode of the season really goes into all of that. And it's actually called Unification 3 because it follows on Unification 1 and 2, which is a pair of episodes in Next Generation's 5th season. No, I don't know all of this off the top of my head. Yes, I had to go look it all up. Despite my sweatshirt, I am not that devoted of a Trekkie to the point where I memorize these things. However, I can memorize them overnight. So what happened was Spock went and he wanted to reunify the Vulcan and Romulan people that had ended up divided on philosophical differences. And didn't happen during those 2 episodes, but the ball kind of started rolling and Spock would stay and finish that. So what we find out is that the planet Vulcan is no longer called Vulcan, it's called Navarre. It is a planet of both peoples who are reunified, but not necessarily well. So there's still a lot of animosity and distrust. There's a blended culture. There's still the Vulcan purists. There's still the Romulan side. So it hasn't quite become some homogenous ball of one culture. And what happened was, in the process of trying to figure out how to deal with the decreasing supply of dilithium, they started this experiment, SB19, and believed for a very, very long time that it caused the burn, and therefore no one else should ever see what the data was, what they did, how they were experimenting. So they've hidden it away. They've basically said, no, you can't have it, and they left the Federation over all of this and various other things. And here comes Michael saying, I need the data on this. And so she kind of gets a little teensy bit manipulated into basically showing up at Navarre as Spock's sister.
Hmm.
Because of course Spock is now a very revered figure for reunifying these people, and she's asked to, present her case, and is immediately shut down. So she invokes a brand new to the Vulcan lore to call in Ket, which is basically defending your thesis,
Yes,
right? I mean, is that how you felt about it, Frank, when
that's
you watched
exact.
it? Was
When I saw this, I kind of reminded me when I defended my thesis, because you have your mentor is nearby you, who basically is supposed to be your ally. And then you have these people who are not really connected to your research, but you have to explain to them your logic, and they ask you questions, and you have to defend yourself. And sometimes you find out that your mentor was supposed to be your ally, which is the case here, is not your ally. The mentor basically stab you a little bit in the back during your thesis. I've seen theses happening like this. Mine was not that bad, I should mention. My mentor was a great mentor. Hi, Renee. She was amazing. So let's just say that. But it did brought back to me some bad memories of stressful moments in my life when you have to defend your scientific ideas in front of people who really don't know well the topic, or start by having already a priori ideas about what you're gonna present. So
right, and they definitely these three people, the quorum came in with their own preset ideas of what they were going to accept. One's like nope, one's like yes, one's all maybe. And of course the really interesting part about this for the plot of the show is that her advocate is her mother.
mhm.
So she's finally found her mother, who has somehow ended up in this Romulan sect of advocates, and she's there to get at the truth. And oh, Michael does not like to dig into how she feels about stuff, does she?
Well, having your mother as your mentor and you co-what Milat sister, monk, whatever, I mean, that must have been very difficult for her. I'm not
I mean,
sure
that would be like having your parent as your thesis advisor too,
yeah,
right? I mean,
which
they
is,
would be
I think,
very,
a
very
nightmare.
no, you should not do that. No, no, no. I love my father, I do, but if he were my mentor, I think it would just be a screaming match. So
Yeah.
no.
So let's go
um,
back to SB19 because I wanted to
right.
mention something. I like this. So this is a network which apparently has been set up to kind of understand more about how we can do transportation through space. Kind of,
Mhm.
it would be a portal, basically. That's the way I'm imagining it. A
Yeah, I mean,
portal.
I'm curious as to see what it really is, but yeah, that's kind of the impression I got.
And in this case, they want the data not for the portal. They don't really care about what the SB19 has been designed to be doing. They want the data because they know that this network probably have measured some kind of perturbation in the space-time or something before the burn. And since this network is everywhere in the galaxy, this network may be able to help them pinpoint the location of this.
Right, it will give them that extra information they
Exactly.
need to pinpoint that place in space-time.
And I like that because that's something we do already on Earth. I mean, there is networks on our planet for instance, there is buoy in the Pacific and all the major ocean in our planet to
Mhm.
basically take measurements of temperature, salinity, the height, and etc. Um, and those has been useful to also detect tsunami,
Right.
for instance.
And then we have the seismic sensors that are everywhere. You can actually drive through the state of California. I know the locations of a handful, and I can point them out to you, where that's just measuring changes in the state of the ground. So what level is it at? Has it moved left or right? Where is that sensor going? Because we have so many fault lines here that are going in different directions that, we have to know what, is this sliding right now? Is this, has it moved recently? And so we have that whole seismic network too.
And what's very interesting is that sometimes we design those sensors for a specific scientific study, and then we realize we could use them for something else, which is exactly what's happening in the show. And we have that example on Earth numerous times, but one of the most, I think, interesting one in my mind is the famous sensor that they designed to, after the nuclear test ban treaty, they design an international organization designed on Earth 320 stations capable of measuring and detect a nuclear nuclear explosion. And what's very interesting is when they turn it on, they realized there was a lot of explosions by infrasound. And those explosions that were not coming from nuclear explosion by human, but were coming from asteroid that basically enter in the upper atmosphere of Earth and get disintegrated. That's what they were measuring. And we're still using those now to basically know how often our planet is being impacted by those asteroids. And sometimes we can even pinpoint from those measurements combined with a CAMS camera, the location, the mass, the size of the asteroid, and find its impact.
Right, and find and actually recover pieces of it. So
Yeah.
our own Dr. Peter Yenniskins has recovered from the Sudan based on some of those, and then he was part of the recovery for Chelyabinsk, and
also in California,
and here in California at Sutter's Mill. So yeah, he's recovered quite a few meteor fragments based on some of these observations. So that's a really great thing. And of course, we love to study those because asteroids are what hit us, and they give us an insight into the early state of our solar system. So they're kind of like that frozen in time sort of piece of what happened before all of the things that have made Earth evolve.
Yeah.
So it's always great for science. I love those.
And I think it's great we have more and more of those measurements, because now with all this technology, this algorithm, machine learning, deep learning, etc., we may be able to better understand our planet. Climate prediction could be better by all these tiny measurements and sensors we have. And there is a large number of people working on that at the moment around the planet. And using those sensors that you can buy for $20, you can put in your garden, for instance. So I kind of like this.
Yeah, and we also in California, another one of those citizen science kind of sensor things is the air quality here.
Yeah.
So there's a network, I believe it's called Purple Air, and
I have it on my phone. Yeah.
Yeah. And so you can measure the particles in the air and know what the air quality is down to a neighborhood, and see like how things like forest fires and other events are affecting the air quality. And I look into that all the time because, I'm one of those people that has problems with bad air, so I have to be very careful. And so it's been really helpful these past few fire seasons. So these sensor networks are really great for adding in layers of different science.
There is one sensor here in the back.
That's right. Of course, your own Unistellar network is also set up now with over 3,000 citizen scientists now.
Yes, 3,000 EV scopes on the planet.
Yeah. So, and you guys have found. You've shaped asteroids. You figured out like what the shape of asteroids are. You've actually caught exoplanets doing transits. I mean,
we're going to announce a new thing in December. You will see something cool that we did with all this small telescope.
Oh, wonderful!
Defense.
I'm excited to see about that one. So all these sensor networks are great. So what we're really hoping is that out of this SB19, that she gets the information she needs. I doubt it's going to be that easy. It is Star Trek, and I'm sure we still have like 5 episodes left, so it's not going to be this easy.
Yeah.
On a personal note, like what did you think of the relationships going on right now? You have Burnham and Book suddenly. Something's going on with Philippa. We don't know what that is yet. And I really loved how Adira Tal modified the spore drive so that Stamets no longer has to like have the arm inserts.
Yeah.
So he just has the goo. And I wonder if that's sort of like leading up to taking this technology to other ships, because now it's no longer so devastating, right? It's not I imagine that you still have to go into the mycelium network and you still have to do all of that, but it's no longer so physically taxing that maybe they could expand this and it might help solve their travel problem.
That's something I don't understand in the show yet, is why they did not focus on trying to understand this propulsion system. So it will solve all the problem.
Right.
It's
And
an
and
obvious problem to solve. Maybe I forgot how complicated it was to have this. So that's maybe the reason. Someone's gonna probably write some comments right now telling
yes.
us you should remember this, but then I
Right.
forgot. So please remind me.
I just remember that it was torture on the giant tardigrade, and Stamets took it over because they couldn't torture. They just couldn't bring themselves to torture this poor creature anymore, and it was rough. So they put the ports in so that it wasn't quite so bad, and so they keep fixing the technology a little bit more, but it's still just one guy
Yeah.
and one spore drive. So I wonder where they're going to go with that, and just how much mycelium do they have on hand at this point. So because every drive is supposed to take some.
Yeah.
I don't know, the spore drive has always been that sort of uh out there trope that keeps this show running, really. I don't want to
Because
question it too
if they were
closely.
running the same technology that the other spaceship, they would be stuck in a base waiting for orders from the admiral, and that would be
Right.
the show.
Yeah, there'd be nothing to do. It'd be like, well, you can't go there because it's, so many light years away and we have no way of getting there. I mean, yeah, and they make that point that this ship is kind of the savior of everything right now. But I'm with you. I'm kind of wondering why they don't sort of backwards engineer this tech and figure out how to do it. I mean, I know it's wiped from the archives and all of the information is pretty much gone on the spore drive, but still, now they have the ship, they can get all that back. And we haven't heard any mention of the sphere in a few weeks
Yeah.
either.
I was also surprised the sphere was not helping with this. Now they have measurements. There is a lot of things like this, technology that pop up and then disappear because it's convenient for the story.
Yeah. Yeah. I mean, that's going to be the case with any science fiction show. So
So
I'm not
thing
bothered by it. It's just sort of a huh.
one thing I really like in this show is that there is a moment of discussion on the role of science in society. It's not clearly said. There is only one sentence which clearly says. That's when the president, I forgot the name, Timira, she says something like, even science cannot be separated from cultural and political context. And
And
that,
I think that's an important thing that we need to remember.
yeah,
Everybody wants to look at science as this very black and white, unbiased kind of thing. And science itself might be, but people are the ones doing science. And a lot of us have biases built in and expectations and, all kinds of things
and
that,
conflicts of interest,
right.
and political or cultural agenda. It does
Hmm.
happen too.
It
Scientists
does.
are human beings, and scientists do make mistakes as well. So we need to always take that into account.
But the good thing about science is that it's a community.
Mm-hmm.
So, that's why we have peer review. That's why we, have replications of experiments so that if someone thinks, oh, hey, that sounds too good to be true, or I don't agree with it, they can run their own experiment and they can do it their own way and figure it out on that, and it can change.
Yep.
Science is not static.
And science has changed, adapted.
Hmm.
Look at the law of gravitation went from Kepler to Newton to Einstein now. So
Hmm.
there is change. And we never say, oh, Kepler was wrong. No, Kepler has a very restrictive way of seeing the universe because it was based on his culture at the time.
Hmm. And
Uh,
the technology available, I mean,
exactly. But it was not wrong. It was just like it was not perfect. And we improve over time with additional theories. And that's the way science evolved.
hmm
But what I really like is this concept of we always need to take into account the cultural and the political background
hmm
when you talk about science, because science is part of the history of this, the moment. So you need to basically know what's going on around the scientist to understand the science that he was conducted or she was conducted at the time.
Right. And the quorum kind of really uh, clearly demarcated that, again, you have the logical purist who is like, I appreciate the logic, but it's not logical to continue on doing this thing. And then you have the Romulan who's, no, we need to do this. We need the information. Like, if this could change things, this could change things. And, so everybody has come in with their own agenda and their own cultural beliefs and everything. And so you can't disconnect the science from that. So it was a good episode. I really liked episode 7. I really liked episode 6. I just feel like there wasn't much science for us to discuss, so I'm kind of glad we ended up combining these.
But that's all for me. I hope we're gonna learn soon the source of this burn.
Yeah, I guess we'll find out. As long as I keep getting more Grudge, I'm happy. I have to say, one of the funny things about episode 6 that really made me chuckle was everybody geeking out over their new badges. And the running joke of the one guy who just kept teleporting into the wrong place at the wrong time, that felt very Orville-like to me. So I really like, again, that this season, that since the second season, they've really embraced humor as part of the script. So these were fun. These were very emotional. I suggest that if you don't recall what happened in Unification 1 and 2, you go watch those. Spoiler alert, they are emotional at various points, but they are very good, and it kind of gives you that background that you need. And I know you also need that for Picard. I haven't started watching it because I don't remember all of the stuff that led up to Romulan reunification. So, all right. Well, I think that covers it for both of us. So that's it. We'll be back next week, we promise. Don't forget to subscribe and ring the bell for notifications. Feel free to leave a comment or 5 with your thoughts and questions. And thank you for watching, everyone. Live long and prosper.
Bye-bye.